Hello and welcome. Today we're going to look at specifying mortars for masonry. And specifically today we're going to look at concrete masonry units, typically referred to as CMUs, and brick masonry. We're not going to discuss natural or manufactured stone, whether it be cast stone or a manufactured stone veneer in this episode, but we will discuss that in a future video recording. And so as we look to specify mortars for masonry construction, and again, we're talking about CMU and brick masonry construction, we actually have a bulletin on our website, which is masonryinfo.org. So you can see that here in my URL. And so if we go to our homepage and we go to tools and resources and come down here to bulletins, it's going to load up the bulletins that we have written, and we're going to be posting probably 2 to 3 more in 2023. And so we will see this list expanded shortly. But as we talk about mortars for masonry, we have one that was written in 2021, which I wrote, which is selecting the appropriate mortar for your masonry project. And so if we click on that, it will expand and we'll talk through different things that we need to look at because this is commonly specified incorrectly. And so we want to clear up any questions that anyone may have. And so in terms of this bulletin, again, we're writing this as the Masonry Institute of Michigan. So this is specifically for Michigan or our Midwest geographical area. But what we're referencing is ASTM C270, which is our standard specification for mortar for unit masonry. And under ASTM C270, it gives us two options for specifying mortars. We can either use what they term the proportion specification or what they term the property specification. And so in your masonry specification or in your general notes, you need to specify mortar according to ASTM C270, and you need to select either the proportion specification or the property specification. In ASTM C270, it does note that if neither of those are specified, the proportion specification will automatically default. And so we recommend, as you go through your specification, using the proportion specification for a couple of reasons that we'll talk about throughout today's video. But even though it will default to that, it's a good thing to include. So here's ASTM C270. And again, this is our standard specification for mortar for unit masonry. I have the 2019 version up on my screen, and you can see here that they have those two specifications noted here, proportion specification and property specification. And it notes, as I just mentioned, the proportion or property specification shall govern as specified, and when neither are specified, the proportion specification shall govern. And the proportion specifications ultimately reference table 1. And so, I'm sorry, table 2. And so table 2 is our proportion specification requirements. And it essentially gives us a recipe of how to mix our mortar. So if we're looking to make a type S masonry cement mortar, we come down here and we essentially need 1 part of type S masonry cement and 2 1/4 to 3 parts of aggregates. And so it just gives us a basic recipe of how we're going to mix that mortar. The property specification is in table 1, and that has requirements for compressive strength, water retention, air content, and aggregate ratio. And what a common mistake is here is because we do have these compressive strength values. This is for the property specification, so that is for a lab made mortar. It is not intended for a field made mortar. And so what we often see happening is that in the field, they're testing our mortar during construction. And the mortar that we're using during construction typically has a higher water content for workability, but that water is going to be removed by the units, whether they're brick or CMU, after it is laid in the wall. And so it's what we're testing isn't representative of what's actually in the wall. And this ASTM does talk about that in section 3.3. It says, since compressive strength values resulting from field tested mortars do not represent the compressive strength of mortar as tested in the laboratory, nor that of the mortar in the wall. Physical properties of a field sampled mortar shall not be used to determine compliance with the specification and are not intended as criteria to determine the acceptance or rejection of mortar. And it does talk about here also property specification requirements in table 1 shall not be used to evaluate construction site produced mortars. And so a common issue we see on projects, again, is we're using those 2x2-inch mortar cubes. They're filling them on a job site out of their wheelbarrow with our site mixed mortar. They're curing them, taking them to a lab, and then testing them for compressive strength. If the compressive strength comes back low, it causes an issue, but we're not really testing what's in the wall, and it's not the intent of this ASTM to test our site mixed mortars based on these property specification requirements. And so just something to be careful of as we specify mortars, that testing, and we'll do a whole nother video on testing, but testing of mortars is commonly done incorrectly in the field. And so if you have questions about that, be sure to reach out. But again, so we were recommending using the proportion specification. In terms of mortar types, our common cement mortar types include types M, S, N, and O. And in ASTM C270, which I just showed you, in the appendix, they have a guide for the selection of mortars, which I have on my screen in front of you. And so it gives you a recommended mortar type and then an alternative mortar type. So for instance, if we had an exterior above grade load bearing wall, ASTM C270 suggests the recommended type would be type N, and an alternate type would be type S. And we'll talk about this as we go through today. And I do have some recommendations that I'll give you from the MIM for projects, again, in Michigan. BIA, which would be our Brick Industry Association, does have a technical note 8B, which is mortars for brickwork selection and quality assurance. That has some recommendations, and so this is a hyperlink that'll take you to that technical note. And the characteristics of our mortar according to the BIA. So type N is going to be our general all-purpose mortar with good bonding capabilities and workability. Type S would be our general all-purpose mortar with higher compressive and flexural bond strength. Type M, high compressive strength mortar, but not very workable. And then type O is a low strength mortar used mostly for interior applications and restoration. So I broke all these down by construction type based on the most common wall assemblies we have here in the state of Michigan. So the first one we'll look at is load-bearing concrete masonry units above grade. And load-bearing does have a specific definition in our TMS 402. I believe it supports more than 200 pounds per foot in addition to its own weight. But you'll have to double check that. And so C270 again recommends type N, like I just showed you, with an alternative type S or M. And for load-bearing walls, specifically exterior load-bearing walls, it's very critical for the engineer to establish an F prime M, which would be their net area compressive strength of either concrete or clay masonry. And so there are tables based on our unit strength method in our TMS 602 that correlate our required net compressive strength of either our clay or concrete units with a mortar type to our net area compressive strength of concrete or clay masonry. Again, the F prime M value. And so if we look at concrete masonry, and what I'm going to recommend, and we do have a bulletin that I'll be issuing on this, is that we use an F prime M of 2000 PSI, because our current specified compressive strength of our units, the minimum value is 2000 PSI under our ASTM C90 there. So if we want to use 2000 PSI in our design as F prime M, if we're using a type S mortar, then our unit strength needs to be 2000 PSI. If we are using a type N mortar, then our unit strength needs to be 2650 PSI. And so for most structural applications, we're seeing type S mortar being specified. And with a type S mortar, if we have a minimum unit strength of 2000 PSI, then we are permitted in our design to use an F prime M or net area compressive strength of concrete or clay masonry value of 2000 PSI. And so what I would recommend is, for any type of unit we're looking at, we recommend specifying the weakest mortar type that will satisfy our structural requirements. And so we recommend using type N or S mortar for load-bearing concrete masonry unit walls, depending on, again, what our structural requirements are. And so I go through an example here in the bulletin you can look at in more depth. But again, in ASTM C90, which would be our specification for load-bearing concrete masonry units, you can see that whether we are a lightweight, medium weight, or normal weight unit, our average minimum net area compressive strength is 2000 PSI. And again, if we combine 2000 PSI units with type S mortar, we get 2000 PSI for our F prime M. And so for most applications, and I would say on the vast majority of projects we see in the state, for any structural CMU wall, whether it's an exterior wall, a load-bearing wall, we're always seeing type S mortar being specified, which is a good recommendation. For non-load bearing CMU walls above grade, so this would not include veneers, this would be something like a partition wall. We recommend using type N or S mortars for interior and exterior uses. Again, load bearing has a specific definition in our TMS 402 building code requirements document. And so this would refer to mostly like partition walls or interior walls. And so in here, I gave an example. If we have an interior partition wall that spans 12 foot from floor to deck, and we have our 5 PSF minimum horizontal load required under our IBC, we could use type N mortar, and that wall would satisfy our code requirements, unreinforced and ungrouted. And so why it matters specifically for non-load bearing CMU walls is as we look at our TMS 402-602, which would be our building code requirements and specification for masonry structures, our mortar type has a big impact on unreinforced masonry construction. So I normally teach strength design of masonry. We'll also talk about allowable stress design. But as we go to chapter 9, which covers our strength design of masonry, if we go down a few pages, we will get to a table which gives us our modulus of rupture values. And the modulus of rupture, as you can see in table 9.1.9.2, is based on our mortar type. So either Portland cement lime or mortar cement, or masonry cement or air and train Portland cement lime. And so you'll see that in this table, for instance, if we look at, it's also based on our direction of flexural tensile stress and masonry type. So if we have a wall spanning vertically, then our tensile stresses would be normal to our bed joints. And if we are ungrouted, like we would be for a partition wall, if we are using a type N masonry cement, we get 31 PSI for our modulus of rupture value. If we are using type N mortar cement or a Portland cement lime mortar, we get 64. So we get over double the value of modulus of rupture. So a lot more capacity out of those mortar types. And you can see the difference between N and S here as well. Parallel to bed joints would be something like perhaps a masonry lintel. And so you can see how that affects things here as well. So that would be for strength design. And for allowable stress design, similarly, we're going to have, as we go down a couple of pages here, an allowable flexural tensile stress. And that's going to, again, be based on our mortar type, our direction of flexural tensile stress, and our masonry type, whether we are fully grouted, ungrouted, or partially grouted, or solid. So you can see the impact that mortar type has here as well. So when we select a mortar for our projects from a structural perspective, it will affect our unreinforced masonry. And because it does affect our modulus of rupture, it will affect things like our cracking moment and our cracked moment of inertia. So it will have an impact on deflection for reinforced masonry construction. So it does have an impact on things. And normally, again, we see type S mortar being specified for anything structural, whether it be load bearing exterior walls, anything like that. If you have a partition wall, we do have a partition guide on our website that gives you our maximum wall heights based on mortar type. And so for partition walls, really, we could use a type N depending on that partition type. And the type N is going to satisfy all of our code requirements. All right, in terms of CMU and brick, and we're talking about anchored veneers here. If we go back to ASTM C270, we do recommend type O, subject to the footnote above with an alternative of N or S. Our BIA tech note, which again is mortars for brickwork, it gives us type N for normal brickwork applications and type S for stronger brickwork applications. And so you can see that here in table 1. So if we have an exterior above grade wall, if we are a veneer or a non-load bearing wall, it's going to recommend a type N. If we are, and our alternative would be a type S. The tech note goes on to discuss bond between brick and mortar. And so it does have a table, which is table 2, which provides recommendations based on our initial rate of absorption, which is commonly referred to as our IRA, and that can affect our bond. And so if we have a very low suction or low IRA unit, so it'd be the top of this table here, it's going to default to a type S because of how that unit is going to perform. If we have a higher suction unit, it's going to go to a type N mortar. So for most applications, we do see type N mortar being used. NCMA or CMHA does publish Tech Note 3-6C, which again, we have a hyperlink to here. And that's going to be for concrete masonry veneers. And they're going to recommend type N mortars are used for concrete masonry veneers. But again, our recommendation is we're going to use the weakest mortar type that will satisfy our structural requirements. So we're going to recommend type N for our veneer walls unless we have a suction rate that requires the use of a higher strength mortar. Load bearing and non-load bearing masonry below grade, we default to ASTM C270, and so we typically see either type M as in Mike or S mortar being specified there. We don't really see type M mortar being used much in Michigan, and so I would recommend just defaulting to a type S below grade. And that covers most of our wall types throughout the state in terms of brick masonry and concrete masonry. Once we've gone through our mortar types, now we have to consider our different cement types. And so in terms of mortar for masonry construction, we could use 3 types of cement. We could use a cement lime mortar, masonry cement mortar, or a mortar cement mortar. And so I have the ASTMs noted here, although I will likely have to update ASTM C150 because the cement industry has primarily moved to using a Portland cement limestone mortar, a PCL. And so that does have a different ASTM designation, and that was in an effort to reduce carbon emissions. So our cement types are limited in seismic design categories D, E, and F. Masonry cement is allowed in those seismic design categories for fully grouted participating elements if we have type S or M mortars. Partially grouted participating elements. So participating elements, again, has a specific definition in our TMS 402. Essentially means shear walls or anything that's part of our lateral force resisting system. But if we have partially grouted participating elements, we are not permitted to use masonry, cement, mortar in these higher seismic design categories. Michigan, we are primarily in seismic design categories A and B. And I believe if we're designing a hospital in St. Joe, Michigan, on the far southwest of our state, we perhaps could get in the seismic design category C. But because we're in lower seismic design categories, we are permitted to use any of these three types of cement in our mortars. So we could use cement lime mortars, masonry cement mortars, or mortar cement mortars. And a lot of this is geographical. The west side of the state, we do see a lot of mortar cement mortars. We see masonry cement mortars being used on the east side of the state and up north. And so, I mean, a lot of it's geographical. You are permitted to specify this in your spec, or you could leave it up to the contractor. But again, this will have an impact on our unreinforced masonry. So if we're designing an unreinforced masonry partition wall, it's going to have a huge impact, and it will have an impact on deflection. So if we have a tall, slender wall and we're running it into issues with deflection, we might have to consider a different type of mortar. And so it does have structural implications. So if you wanted to be conservative, you could run your structural calculations with a masonry cement mortar and then permit the contractor to use any of these three. And if they use a mortar cement mortar, you know that you're safe. But if you're using something like a mortar cement or a cement lime mortar in your calculations, you want to be sure to specify that value. So that goes through all of our different types of cement for mortar. We've covered quite a bit in this video. And so I do have a brief summary here in our bulletin on our website. And again, I mean, if I had to boil it down to one statement, the MIM recommends specifying the weakest mortar type that will satisfy our structural requirements. In general, that's because if we have any settlement, deflection, anything that causes distress in our wall, we would like the cracking to occur in our mortar joints because it's easier to tuck point a mortar joint than replace units. And so if I had to boil it all down, we're going to recommend specifying the weakest mortar type that will satisfy our structural requirements. Because we are in low seismic design categories, again, you could just leave it up to the mason contractor as to what they're most familiar with, because largely the cement types are geographic in their usage. And so if you base all of your calculations on using a masonry cement mortar, which would be the most conservative, because again, that has the least strength, then if they select to use a mortar cement or a cement lime mortar, you know that you're safe. And lastly, I did put this flow chart here to try to make all this simpler. So if we do have a brick or CMU veneer above grade, if we have a suction rate or an IRA greater than 10, or a CMU veneer, we are using a type N mortar. If we have a low suction brick with an IRA less than 10, we are using a type S mortar. And we run into issues if we're specifying too strong of a mortar in a veneer that it's harder to clean, and we could perhaps damage the units during the cleaning process. So type N unless we have a low suction brick veneer. In terms of load bearing masonry, interior or exterior above grade, type N or S. And again, this is going to have an impact on our F prime M, as well as our modulus of rupture or allowable flexural tensile stress. Non-load bearing, again, N or S, and then below grade type M as in Mike or S. And so I will say typically we do see type S being used for anything structural. So if we have a load bearing wall or even a non-load bearing wall, typically we are seeing type S, and that's perfectly acceptable. And below grade, we are typically seeing a type S. And in terms of all of our references, we did base this on our 2015 International Building Code, which adopts by reference our 2013 Building Code requirements and specification for masonry. The document that I showed you here is 2016, and there are no differences in our tables for our allowable flexural tensile stress or modulus rupture between those codes, so that's fine. And you also have links to the BIA technical notes and CMA tech notes, or CMHA, and the tech note on mortars for concrete masonry. So thanks for listening. I hope this clears up a little bit as far as specifying mortars for masonry. And again, this goes through brick masonry and concrete masonry, which would be our typical CMU type of construction. I will record another video in the future on natural stone and cast stone because we have to be a little bit more cognizant of mortar types and suction rates as we look at those units. But that's all for now. Any questions, please reach out through the website or email me, and I'd be happy to review your spec and help you on your project. Thank you.